Hey team, Andre from High Performance Academy here. Welcome along to another one of our webinars. And this week we're going to be diving into the technique of concentric twisting. We'll find out what that term even means, and it is one of those terms that we see thrown around a lot, particularly out there on Instagram accounts for those who are building professional motorsport wiring harnesses. As we'll go through today's lesson, we'll find out what the term means, why the technique is used, and we'll have a bit of a demonstration here live as well of actually producing a short section of concentric twist, because this is something we always get asked in our webinars on wiring. How do we actually perform the concentric twist? So we'll go into that in a bit of detail as we go through the lesson. Before we dive into that though, just a bit of an update on things that have been going on around the workshop over the last couple of weeks since our last webinar. And again, we are full steam ahead on our SR86 endurance car prep. We have just on 2 weeks left before the first round of our endurance series. This one will be our local track, which at least gives us a bit of an advantage. It's a track we know pretty well, but we typically are still making some last minute adjustments, changes to the car. One of them not so minor either. And if we jump across to my laptop screen for a moment, this is our newest addition to the car, which is a Hollinger SG3 gearbox. And we have been running a sequential gearbox in the car for a while. It was a manually shifted gearbox, and we have had a few reliability niggles with the gearbox, and we had been chasing a high-speed vibration with it as well. So long story short, we decided for ultimate reliability and hopefully a gearbox, fingers crossed, that we don't need to worry about for the 4 endurance rounds that we're about to go into, the Hollinger probably made a little bit of sense. Now, as part of that as well, as I mentioned, this one is not a manually actuated, manually shifted. The section that we've got on the back here, this is the air shift mechanism. So it can still be a conventionally shifted gearbox. You can either have a gear lever directly fitted, which is what this black blanking plate here is for, or it will also run a remote actuator as well if you want, depending on whereabouts the gearbox is located versus your shifter. So we have opted to go here with a paddle shift arrangement for it. So you can see here we've got a little Penny and Giles gear position sensor as well, which is key to this. Obviously with paddle shift systems, there's a lot of things going on at very, very high speed, and to make sure that the shift is going to actuate correctly and reliably and consistently, the ECU, in this case our Motec M150, needs to precisely know the position of the gear shift barrel so it knows when the next gear is properly engaged. Behind here, you can see those 2 little actuators there are for our upshift and downshift. So basically all we need to do is supply high pressure air to that. As part of this is the MME Motorsport compressor and reservoir for our air pressure. So this is what's going to provide air pressure to the shift system when the ECU requests a shift. So nothing particularly over the top there, pretty simple little system. And as part of the MME kit, we also got a pair of their magnetic paddles as well. These just mount straight in behind our existing steering wheel. So the way we're going to actuate these is obviously a few options. We did consider the idea of directly wiring them. However, we do already have our ECU Master CAN switch pad on the back of the steering wheel. I've got a couple of spare switched inputs on that CAN keypad, or switch pad I should say. So why we went with that, if you haven't been following along for a while, that little CAN switch pad allows us to bring in all of the switches and analog adjustments on the steering wheel that we've got there. So we've got traction and boost control, for example, with multi-position driver switches, and then switches or buttons I should say for things like our pit limiter, for a push to pass and to talk on the radio, among other things. So all of those, rather than wiring them individually, which gets a little bit tricky with a curly cord, we've just wired these up to our CAN switch pad. That converts them into a CAN message. Then we only need 4 wires running from that CAN switch pad through the curly cord. So we've got CAN high, CAN low, and then 12 volts and ground. So it's converting those to a CAN message, and We did consider the reliability of a CAN system. The reliability these days, though, it's a very well-developed system. You're going to find this in basically any professional level motorsport vehicle anyway. The amount of CAN integration that we have, even in our relatively simple Toyota 86, if we had an issue and the CAN bus went down, we're going to have major problems getting the car to the end of the race anyway. So we made a conscious decision to send those requests from the paddles via CAN. Those go into the Motec M150 ECU and then get processed. There's a few things that we actually need to do, of course, to fit this gearbox. Part of it's quite easy because it does come with a CNC machined adapter at the front to the SR20 bell housing, which is exactly how our existing sequential fitted. So that part, which is normally the tricky part, very, very easy. We did need to make a gearbox mount, so Jimmy, our fabricators, machined up this little mount here that goes onto the back of the Hollinger, and just basically has a really simple Nolithane bush and then a fabricated mount that goes out to the trans tunnel. Just coming back here as well, one of the nice features with the Hollinger is it does have a built-in cartridge filter, making it really easy to filter and check the oil. Also with endurance racing, generally you're going to always need to run an oil cooler for your transmission. We've got one on our differential as well, and currently we're running an external electrically driven pump, and the Hollinger actually brings this internal, so that's a nice simplification of our system as well. As part of that oiling system, I wanted to make it really easy to remove and install the gearbox. My philosophy is if we make this really easy, chances are we're probably not going to have to do it very much, which would be absolutely perfect. So we've got a bit of a limitation in terms of clearance between the gearbox and the sides of the transmission tunnel. We haven't got both of them in sight, but here we can see one of the transmission oil lines. So that's where it comes out of the side of the gearbox. Obviously there's another one somewhere back there. So these get quite tight to the side of the transmission tunnel. So getting in there with your AN spanner and removing these and getting transmission fluid all over you, not a lot of fun. So to simplify that, Brandon made up these hard lines, which you can see here, and they're terminated near this is that CNC adapter plate that I was talking about as well. So they basically terminate just behind the bell housing, and we're using a pair of these Jiffy type dry brake connectors. So the idea with these is that, as the name implies, they're a dry brake. We can basically remove and reinstall those lines without introducing air to the system. Not that that's specifically a huge issue, but more importantly for our purposes, it's going to not end up leaking gearbox oil all over whoever's working on it. Anyone who has ever removed a gearbox before will probably understand that gearbox oil is not the most pleasant thing to have all over you, and probably normally your clothes as well. So these should be a nice solution to that. I talked about air introduction there. So while we don't have them on our car, these are quite often used for more sensitive hydraulic systems like the brake system and the clutch system, where obviously any inclusion of air into those systems is going to be really problematic. It's personally not something I probably want to do, but I know a lot of people do use these or similar systems for that sort of application. So we're getting pretty close, and we are expecting hopefully to have that car back on the dyno tomorrow. There's some calibration work involved in getting it set up for the new paddle shift operation. We've also made the shift from a 4-port boost control solenoid to a 3-port. I won't dive into that too much, but essentially 4-port gives us a wider range of boost control from the minimum wastegate spring pressure up to the maximum we can run. We use these a lot in drag racing where we need to leave the line relatively soft, but then obviously run a lot of boost and a lot of power in the deep end where the car is not traction limited. We didn't need the range of boost control that I initially was expecting, and really the 4-port was wasted on the car. Another aspect which is really easy to overlook with the 4-port solenoid is that it does reduce the resolution available to us when we are making adjustments to our boost control duty cycle. What I mean by this is making a 1% increase in our duty cycle to our solenoid has a much bigger effect on the boost that we're actually going to see when we're running a 4-port solenoid compared to a 3-port solenoid, and this can influence the effectiveness of our closed loop boost control strategy. So we've dropped back to a 3-port, and obviously again that's going to require a little bit of optimization on the dyno to get that dialed in. So fingers crossed, if everything goes well, we should be in a reasonably good position to head to that first round of racing, but we've been in this position before. I'm not counting my chickens just yet. We're just hoping that everything goes our way. After last year's fiasco, I think we probably deserve a bit of a break. All right, now other exciting news as well. We have just released, as of yesterday I should say, a brand new course. So we'll head over to my laptop screen for a moment. So this is our suspension tuning and optimization course. It's a pretty far-reaching concept, and I just want to talk a little bit about this because this is something we've been asked about so many times. Two of the most common questions we get in our race car setup and optimization, data analysis, and wheel alignment webinars is, how do we know what spring rate to choose? And follow closely behind that is, how do we know how to adjust our bump and rebound settings on our suspension? So we went to quite some trouble to develop a course specifically around this, and I'll just take you through it. It is $149 US, as you can see there. You can break that payment down as well into 8 weekly payments. I'll talk a bit more about that in a second, but I just want to take you through some of the fundamentals of what's included in the course. And we start with some of the basic concepts that you're going to need to understand. Now, a lot of you probably already have a pretty good understanding of some of these at a broad level, but Tim dives really deep into these. Even something as simple as the purpose and role of a suspension system, and that might on face value seem pretty straightforward, but there is a little bit more going on here, and particularly when we look at some relatively basic passenger cars, pedestrian cars I should say, that a lot of us are driving day to day. These are obviously designed for cheap production and getting from A to B in relative comfort, and that's fine for their intended purpose. When we get our grubby mitts on them though and want to start developing them for racetrack performance, obviously the OE design was never really optimized around racetrack use. So there's a lot of pitfalls and things we need to understand there. And we talk about the different suspension types as well. There's obviously a lot of different types, each with their own pros and cons. Some of the more tricky concepts that are again really important, talking about sprung versus unsprung mass. The unsprung mass is considered to be the weight of aspects such as our wheels, tires, the hub, the brake assembly, etc. And trying to reduce the mass of our unsprung mass is really, really important to get the components to track the bumps and undulations in the road really well. We talk about another area that I see a lot of people get confused: suspension travel and motion ratio, and then suspension frequency, which is really important because this comes into calculating our desired spring rates. Then we move into our springs, anti-roll bars, and bump stops, and we talk about what these are, the influence of each of them on the suspension system. And I've got bump stops in there. Tim added this in, and you may be thinking, well, the bump stop really isn't a suspension component that we should be worrying about, right? Now, that's really considered to be sort of last line of defense. If we have a problem with our suspension, we really bottom it out, and that's there to prevent damage. Well, to a degree that's true, but when we particularly get into some of these cars with very high aero downforce, the bump stops can actually be a really, really important tuning tool to limit the amount of suspension compression at very high speed, where that downforce is really pressing the car into the ground, without needing to go to an excessively stiff spring that will then compromise the mechanical grip in low-speed corners where we don't have that aero. Likewise, anti-roll bars, really useful tuning tool, particularly in some of the race cars where they are adjustable inside the cabin. But even these days in our modified road cars, you're going to find companies like Whiteline producing relatively cost-effective anti-roll bars with multiple adjustment positions on them. And that's a really powerful tool to adjust your balance between understeer and oversteer, get your car handling how you want it to. We then talk about dampers, and these are something that I know a lot of people are confused about: the purpose of the damper, how the damper it actually works. And understanding this is really important if we want to get to that next obvious step of how do we know when we've got our suspension, how do we optimize our bump and rebound adjustments. We also talk about suspension geometry in here as well. Some of the concepts here, such as instant center, roll center, and axis, pitch center and axis, and some of the anti-effects such as anti-dive and anti-squat. These are starting to get a little bit more niche, and these are the areas where I know a lot of people really struggle to understand them. Very, very important principles. Then we get into also actually modeling the suspension as well, with an introduction to some of the simulation tools that are available. I'll go over a little bit quicker here because I'm not going to dive too much more into it. We'll talk about lateral load transfer, the basics of this, which is really important to understand. And then we get into some of the practical skills. So these are actual skills that you can apply, such as measuring and calculating a center of gravity, measuring a motion ratio, anti-roll bar stiffness, set up procedures, choosing your springs, choosing your anti-roll bars, and then tuning them, choosing and tuning your dampers. So if you are interested in that course, as I mentioned, $149 US, as always, comes with a 60-day, no questions asked, money back guarantee. You can split that payment down into 8 weekly payments. I'll just dive back. I think it comes down to about $18 US a week. It does, yeah, 8 weekly payments, $18 US a week. And regardless of how you purchase though, remember you've got 60-day, no questions asked, money back guarantee. Purchase of that course will also give you 3 months of gold membership with access to our forums, where if you've got questions that you don't feel were quite answered or something specific to your car, you can jump on our forum and get help there. So I'll get a link dropped into the comments that you can follow to get to that course, or check out hpacademy.com/courses. Scroll down there and you will find that course. We are really excited about it, and we know it's going to help a lot of people. All right, moving on, I just want to cover an Instagram. Now, this is a bit of an older one. I actually took this photo back at Goodwood Festival of Speed back in 2019, I think it was, when we were over there. And this is a Mercedes 190e DTM car, and running slide throttle bodies here. And this is more not just about the DTM engine with the slide throttle bodies, but anything running individual throttle bodies. I just wanted to talk about the fact that when we run individual throttle bodies, rather than the conventional speed density operating system where we use manifold absolute pressure on the load axis, typically here what we actually do is we revert to using what's referred to as alpha N, which is where we have throttle position on the load axis for our fuel and ignition tables instead of manifold pressure. Reason being that manifold absolute pressure in a situation like this, first of all, is difficult to measure, but not impossible. We can run balance bars where we take a vacuum source from each of the runners post throttle body. But even then, it doesn't actually give us a very good indication of the load on the particular cylinder that's on the intake stroke. It's because we see quite big oscillations in the pressure in the manifold as the intake valve opens, and that can be problematic compared to having a large plenum with a single throttle body, which is more conventional. And one of the little tricks when we are using alpha N that I know a lot of people overlook is that the airflow, particularly through a conventional butterfly style throttle body, is really non-linear. What I mean by this is if we open our throttle from completely closed, let's say 5%, then we open an additional 5%, we're not doubling the airflow. What we actually find is that we get a really large increase in airflow initially as we open the throttle butterfly, and then as we continue to open the butterfly, we get less and less increase in our airflow. So the biggest changes from closed throttle to perhaps 5 or 10%. And then at the other end of the spectrum, from 90 to 100%, we've got very, very little change in our airflow. Now, what this means is that when we are setting up our maps in our ECU, particularly as far as our fuel table goes, which is a little bit more sensitive than ignition, it's a good idea to take that into account when we are choosing the breakpoints for that axis. So what I mean by this is I probably wouldn't be setting my breakpoints up at 0, 10, 20, 30, 40, 50%. Instead, we might go 0, 2, 4, 6, 8, 10, then maybe 15, 20, then 30, 40, 50. By the time we get out to 70 or 80%, we can actually start stepping in 20% increments. So we'll just take into account how that airflow increases and making a logical choice and a smart decision when it comes to choosing the brake points for those axes. It's going to give you more control of the fueling down in that part throttle area, and getting that right is going to make for a car that drives much, much nicer, gives better drivability, better throttle response as well. Obviously, all of the things we want in our car. All right, I just want to also mention, I have touched on this before, but I just want to go a bit deeper. We've got a brand new podcast out. So we've got a podcast which we launched a little while ago, which is called HPA Tuned In. We can head over to my laptop screen. You can find this at hpa-tunedin.com. It is available wherever you're probably already listening to podcasts. Apple Podcasts is always my go-to, but I know a lot of people prefer Spotify. Whatever, we've got you covered. So we're going to be releasing an episode of this every week. We've got some really great ones coming up. The last episode that we just released, which we can see here, is an episode with Chris Wall, who actually used to work for me in my old business, STM. And when we basically made the move to start High Performance Academy, Chris went his own way and has started his own tuning company called Prestige Tuning and Motorsport. So we talk to Chris about the process of getting involved and learning how to tune, and a lot of his experiences along the way, particularly with handling customers that want big flames, as you can see with that title. So we would love it if you could check that podcast out. If you are a podcast listener, it's going to be a great way of adding some more automotive content to your existing diet. I'd really love it if you could also leave us a rating and a review. This is going to help us reach more people and give us more visibility with that podcast. So some really great podcasts coming up. Last week interviewed, in no particular order, Tony Palo from T1 Race as well. We've got him coming up. We've also got Sander from Obsidian Motorsport Group, and also Scott Hilzinger, or the Tuning Fork from Haltech as well. So some really interesting conversations coming up there. All right, we will leave it there. Thanks to everyone who has watched today. Give me a few moments here and we'll get started with today's lesson. If you like that video, make sure you give it a thumbs up. And if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.